Okay, so we are wrapping up the Chapter 6 material today with 6.7. Obviously, we skipped some sections, and that's just to kind of hit some of the important topics. So today is systems of inequalities. And the nice thing about systems of inequalities is you're going to approach these a lot like systems of equations. And so if you can graph a system of equations, you can graph a system of inequalities. There's just a couple of little things that we have to keep in check that we don't have to keep in check with a system of linear equations. So first thing is a linear inequality in two variables can be written like ax plus by is less than c. Obviously that less than symbol could be less than or equal to, greater than or equal to. It can be any of your inequality symbols. The a, b, and c need to be real numbers, and a and b cannot be 0. So really, a linear inequality in two variables is the same thing as a linear equation in two variables, except that your sign is different. So instead of dealing with an equal sign, you're dealing with an inequality sign. And when you solve an inequality, you don't get just a nice answer like x equals 2 and y equals 3 where you have an ordered pair. What you get is you get a whole range of qualities that work for the inequality. That's the differences. So when it comes to graphing these things on our Cartesian coordinate system, really you can think about replacing your inequality symbol with an equal sign and then graphing it like a line. Like you really can. The difference that you're going to see here when you're graphing it, though, is that if you have an inequality that is strictly less than or an inequality that is strictly greater than, you're going to use a dashed line. Because what that means is the solution you're finding for that linear equation, for the linear inequality, doesn't actually fall on the line itself. And so we use a dashed line to indicate that nothing that's on the line actually works for our inequality. That line becomes almost like a boundary of where our values work. If we have the less than or equal to or greater than or equal to sign, you're going to use a solid line just like a regular linear equation. So the way that I always try to point out is that if your inequality has a line, like the less than or equal to or the greater than or equal to does, you're going to use a solid line. So if your symbol has a solid line, use a solid line. If your symbol doesn't have a solid line, use a dashed line. And then after you graph the line, or the inequality, however you want to think of it, you're going to pick a test point on either side of your line, and you're going to see if you get a true statement or a false statement. If you get a true statement, that's the side you're going to shade. Because, like I said, instead of getting all of our answers lying on the line itself, what we're getting is one side of our, because what happens is we end up like cutting our graph. So if that's our line, oh, thanks. If that's our line, what happens is we've now cut our Cartesian coordinate system into two sides, the left side and the right side. So one of these sides is going to actually have all the values that work for our inequality, and the other side doesn't. And in order to figure that out, we have to pick a test point. We plug it into our inequality, and we see if we get a true statement. If we get a true statement, then what happens is that's the side we're going to color or fill in. So we graph it just like a line. Differences are dashed line versus solid line, and then we have to do some shading. We're going to do 3 examples. We're going to do an example where we have just one linear inequality, where we have a system of equations with 2 equations, and where we have a system of equations with 3 equations. Am I good to take this off the screen? Cool. Because those are all the actual notes. Now we're just going to do some examples. So since we can treat these just like linear equations, what I recommend doing is always getting your inequality to look like y equals mx plus b. Because if you get it to look like y equals mx plus b, you can plot your y-intercept and then use your slope to plot your next point. If that's not the way you like to graph your linear equations, if you like to use your x and y intercepts, you can use that for this as well. If you like the point plotting system, you can use that method as well. I think those usually take a little bit longer, than just getting it as y equals mx plus b. And sometimes, like this one, it's going to already come in that format. This already looks like y, whoops, I said y and I wrote m. Y, and then your inequality symbol, mx plus b. It already looks like that. So what is my y-intercept for this inequality? No. Think about it like a line. So we have a line, y equals mx plus b. Which of these letters is the y-intercept? The b. That's what we would graph first. So that's the same thing for here. Don't worry about that inequality symbol. And if it makes you uncomfortable, pretend like it's not there. You can write this as y equals x plus 3, and we can think about it like this for right now if that makes you more comfortable. But either way, the b is 3, so we're going to go up 3, and we're going to plot that. And once we have our b, we find our next point by graphing using the slope. So what is the slope of this inequality? 1. So I'm going to go up 1 to the right 1. And I'm going to plot that. Now, before I connect these, I'm going to look at my inequality symbol. Does my symbol tell me I'm going to use a dotted line or a solid line? Dotted line. So I'm going to do a dotted line to connect those. Okay, so I've graphed the linear inequality, used my dashed line. Now is when we will do our test points. So notice we have up here and down here, kind of like we cut it in half-ish. The point I always recommend testing first is 0, 0. If it doesn't lie on your inequality, test that because algebraically that's going to be the easiest one. So if I'm testing the point 0, 0, I'm going to plug 0 in for my y and plug 0 in for my x. And right then I get 0 is less than 3. Is that a true statement or a false statement? True. So since that is a true statement, I'm going to shade this side of my inequality. Had that been a false statement, I would shade the other side. You're always going to shade a side, so I would shade one side that gives you the true statement. And you can always test. We could pick a different point over here, like 0, 4, and we could plug that in. If I plug in 0 and I plug in 4, whoops, the other way, 0 and then 4, then I'd have 3 is greater than 4. That's false. So it shows you that you get a false statement on the other side. On my math lab program, when you graph your line, there's an option to graph with solid or dashed lines. So you have that as an option. And then there's a paint bucket. And you dump the paint bucket on whichever side you need to shade. So treat it just like a linear equation. Graph it using your y-intercept and your slope, or whatever format you like graphing your lines, but I think that's the easiest. Then before you actually connect the points that you've plotted, check to see if you're going to use a solid or a dashed line. Do that, and then do your test point. Questions? All right, let's look at a system. We've done a lot with systems. We've graphed them. We've talked about inconsistent, consistent, and dependent systems. You can have those with inequalities as well. I will go ahead and tell you I did not give you any systems of inequalities, though, that are not consistent. So they're always going to cross somewhere. That way you get nice spots for shading. Now, neither of these are written in y equals mx plus b format. So that's going to be my first goal. I'm going to isolate my y's. For this top one, I'm going to subtract the x over so that I have y is less than or equal to negative x plus 4. And then in order to get my other one moved over, I'm going to add the y over and subtract the 2. So that I have x minus 2 is greater than or equal to y. And then I don't like it written that way because I like it to be y equals mx plus b, like written in that format. So I'm just going to flip it around so that it looks the same. From here to here, I did nothing algebraic. I just wrote it in a different order. And I don't know why I wrote it in green, but I did. Because my green one is going to be this one. My other one will be red. Y is less than or equal to x minus 2. Okay. Now we're going to graph these just like a system of linear equations. So if I'm looking at this top equation, this y is less than or equal to negative x plus 4, what is the y-intercept? 4. So I'm going to go up 4, 1, 2, 3, 4. And what is the slope? Negative 1, down 1, right 1. Then will I be connecting those using a solid or a dashed line? Solid. Okay, so there's the top one. The bottom one was y is less than or equal to x minus 2. What is the y-intercept for that one? Negative 2. And the slope? 1. Positive 1, up 1, right 1. Am I going to connect using solid or dashed? Solid. So this one literally is just like doing a system of linear equations. Now, they could also ask you for the vertex. If they ask you for the vertex of your system of inequalities, that's simply where does it cross. We don't call it the solution because you're going to get a whole range of solutions. But where they cross can be called the vertex. So just be aware of that if your problem does ask you for a vertex. Okay, and then different from our last one, we had one line, so we had 2 different sides to test, theoretically. This one, with 2 lines, we have 4 different quadrants, as it would be, that we might have to test. And it really kind of just depends on how lucky you are at guessing your test points. There's no good way to pick a test point, except that I always start with 0, 0, just because algebraically it's the easiest. And so that's what I'm going to do. I'm going to pick 0, 0, that lies over here, and I'm going to test it. And since we are dealing with a system of equations, or inequalities rather, I'm going to have to test it in both. I can't just test it in one. So if I have 0, 0, 0 plus 0 is less than 4 for this top one. That's true, 0 is less than 4. For the next one, I have 0 minus 0 is greater than or equal to 2. So is 0 greater than 2? Nope. So this one's out. That one didn't work. So now we have to pick a test point in one of the other quadrants. Usually I pick a test point that lies on one of my axes, just because one of the values will end up being 0. But you can pick literally any point that lies in any of the quadrants and test. So what would you like the next test point to be? 0, negative 3, so down here. Okay, so for that top equation, I would have negative 3 is less than or equal to 4. That works. For the bottom equation, I would have 0 plus 3 is greater than 2, so 3 is greater than or equal to 2. So that works. Once you get a true statement, you are done. You will only shade one section. So if you luck into finding that section quickly, then you are done quickly. Pretty sure based on the thing that I have on my homework, I was not lucky. And I tested all 4 quadrants. And that can happen. Because if you just, like, I think I started here at 0, 0, and then I just went around. And because I went around, I got back around to that one last, and that's just how it works. So the test points are important because you do use those in other areas of math where you have to pick a test point. I'll be honest though, I didn't learn graphing these with test points. And so on the next example, I'm going to show you how I learned it. And there's nothing wrong with the way that I learn it, but we do want to make sure we can do test points if we need to, because you'll use those in other classes. But this next method that I'm going to show you, at least on the shading aspect, it does work as well, okay? And I think it's a little bit simpler. We're going to graph a system of equations that has 3 equations, but there's still only 2 variables. We have an x and a y. So it's not like we're trying to graph in the 3D plane or anything like that. And I am going to get all of my equations, or inequalities, excuse me, to look like y equals mx plus b. Is that what you guys got?
I got y is less than or equal to -3 minus 6.
Y is less than or equal to -3 minus 6. What did you do?
Oh, I see. So I didn't divide the -1 across the
Okay.
inequality.
But then when you divide by a negative, you have to flip your sign. So you subtract your 3x over, which makes it negative. Your 6 was positive. And then when you divide, we have to flip that, and all those change. Okay? So we're going to take them one at a time. I'm going to start with the top one. I'm going to graph it first. So I have y is greater than or equal to 3x minus 6. So what is the y-intercept for that? -6. So I'm going to come all the way down here to -6. 1, 2, 3, 4, 5, 6. Okay, I thought I did 6. Plot that point. And then what was the slope for that one? Yeah, +3. So I'm going to go up 3 and to the right 1. 1, 2, 3, to the right 1. And then, am I going to use, actually, let's just go ahead and be honest. Look at all of ours. They're all like greater than or equal to or less than or equal to, so they're all going to be solid lines. So no dashed lines for this one. All right. So there's the first one. Now, I'm going to show you the way that I approach shading. Okay? This is the line representing the inequality for this red line, the very first one. And it says y is greater than or equal to the 3x minus 6. We just graphed the 3x minus 6. So looking at just this line, and if I'm thinking about y being greater than this line, are my y's greater than this line over here or over here? On the left. Yeah, because my y's keep getting bigger, right? So theoretically, if I was done, I would be shading this side. So I'm going to make these little arrows that let me know that that's the side I would be shading. And you could actually test that. If I plug in 0, 0 into this top equation, which falls to the left of my line, I would have 0 is greater than or equal to negative 6. It does hold. But what I'm doing is I'm looking at the inequality and I'm figuring out which side it is instead of using a test point. You can still use a test point. I'm just showing you an alternative method. Okay? Now let's do the green one. Y is less than or equal to 3. How do we graph that? Yeah, it's a horizontal line at y equals 3. Remember, y equals a number is horizontal. Where x equals a number is vertical. So the same thing holds true if you have inequality symbols. So if y is less than or equal to 3, I'm going to go up to 3, and you can plot any 2 points along that line. It does not matter, as long as it's going to be horizontal, which if you're making your own tick marks, horizontal-ish. You know, I know it's weird to draw a straight line. Yeah, that's definitely an ish line. But then the question becomes, if y has to be less than or equal to 3, would that be above or below the green line? Below. So if I was only shading the green, off the green, I would shade below that. And if we were done, like if that was our system of equations, 2 equations, 2 unknowns, can you figure out which section we would color in? Yeah, bottom left, because we have our green arrows pointing to that one and our red arrows. Up here we have a red arrow, but there's no green. Over here we have nothing. And over here we have green but no red. So the only place they intersect or would overlap is over here. Do we see how that's working? Okay. But we're not done because we're doing 3 equations. So we have this last one. Y is greater than or equal to negative x. What is the y-intercept for that inequality? 0. And what is the slope? Negative 1. So I go down 1, right 1. So notice with 3 lines, I have a lot of different sections. I think I have 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I have 7. So if I did the point plotting method, I could potentially have to test, or not point plotting, but if I did the test point method, I would potentially have to test 7 different points into all 3 of those equations. Which is why I wanted to show you this alternative method for finding your shading section on this one, because I don't know about you, I don't want to test 7 different points and 3 different inequalities. Like that could be up to 21 different calculations. Don't want to do it. So let's look at just the black line for a second. My inequality states that y has to be greater than or equal this black line. So is that going to be above it or below it? Above it. So I'm going to go this way. So where is the only section on this whole graph where everything overlaps? Yeah, that middle triangle-y thing. My green goes in there, my red went in there, my black goes in there. So that is the section that I would graph. And we could pick a point. And this is what I do recommend. If you do use this method where you are looking at the overlap of the different regions, I would recommend taking the time and picking a point like 0, 2. That lies in that shaded region. And then I would go test that one point, 0, 2, in our 3 inequalities. And make sure you do actually get a true statement. It kind of gives you a smarter way to pick your test point so that you're picking what you assume is the correct test point or the correct region. instead of just randomly picking out of the 7 different sections and then having to test a whole bunch that way.